In this video, we're going to use the alternating series test, but we're going to notice that the alternating part of the series is slightly different than what we typically see. So in this case, we're asked to determine whether the series from 1 to infinity of n times cosine of n pi over 2 to the n converges or diverges. Well, and notice that usually when we see an alternating series, we have a negative 1 to the n or a negative 1 to the n minus 1 as our alternating part. But that's not the only way you can write an alternating series. In this case, notice that we have the cosine of pi, n pi here. When n is odd, this is going to be negative 1. And when n is even, this will be positive 1. So the cosine of n pi here is really taking care of the alternating part. All right, so if we want to apply the alternating series test, we need to consider the terms n over 2 to the n, the non-alternating part. Certainly those terms are positive for positive n, so we need to see that it decreases and goes to 0 to be able to apply the alternating series test. Again, for decreasing, you can probably note, of course, that 2 to the n certainly gets bigger faster than n does. We can verify that with a derivative. Let's let our f of x be x over 2 to the x. Take your derivative using the quotient rule. And of course, remember that derivative of 2 to the x is 2 to the x log 2. Simplify by factoring out a 2 to the x on top, and you can cancel a 2 to the x with a 2 to the x quantity squared. That's what 2 to the 2x is. And you're left with a 2x on bottom and a 1 minus x log 2 on top. Certainly here, log of 2 is less than 1, so I need to get bigger than 1 before this is negative. Pardon me. This is going to be equal to 0 at 1 over log 2, which is between 1 and 2. You can check with a calculator. But in particular, this derivative will be negative when x gets at least 2 and bigger, which means that our sequence of terms, n over 2 to the n, is eventually decreasing. So now we want to show that the limit of those terms is also 0, so that we can apply the alternating series test. In this case, it's probably easiest to use L'Hopital's rule, because when I take the derivative of the top, we just get 1. When we take the derivative of the bottom, we'll get 2 to the n log 2. Everything here is a constant except for that 2 to the n. As n gets big, 2 to the n gets big, so the fraction gets small, and it goes to 0. So the alternating series test applies, and we can conclude that the original series converges.